Built in 1997, the Leonard P. Zachem Bridge was under construction for 6 years. After its completion date in December 20, 2003, the bridge had 4 lanes in either direction. However, an additional 2 lanes were added for a local cantilever ramp in 2005. Designed by Theodore Zolli and Christian Menn, then built by lead construction engineer David Goodyear, the bridge became an instant icon in the city of Boston. This is due to its unique and eye-catching wishbone-shaped towers. It also features an interesting cable arrangement due to its connections to both the tower and the triangular arch. The bridge consists of steel cables attached to both composite steel reinforced concrete pylon heads and main span, as well as the pre-stressed concrete side spans. Cable-stayed bridges differ from traditional suspension bridges in that all the cables run directly into the towers. Suspension bridges typically have secondary cables connecting the tower cables to the span surface perpendicular to the bridge. When designing the model to be printed, the first step was to draw a rough outline of the tower. We had to approximate the lengths and angles as the only dimensions we had for the tower were the total height and the height of the road above the ground. We got these dimensions from structureae.net. From this data and numerous photos of the bridge, we were able to estimate the dimensions to make a 1:1000 scale model. After finishing the tower, we sent it off to be printed. This tower ended up being small, so we decided to scale it up by a factor of 2.5 and sent it off to be printed again. We then began work on the road spans. Once again, we estimated the dimensions based on the data from structureae.net. When making the span between the 2 towers, we realized the part would be too large for the printer, so we split it into 2 separate parts. Each of the road span parts have a male and female connector to make assembly easy and ensure they wouldn't split apart when put under a load. At this point, we got the printed 2.5 times scale towers back from the printer, but they were too big, so we scaled back all the parts by a factor of 0.5. Finally, we assembled everything in SOLIDWORKS to make sure they would all fit together properly. We did not model the cables in SOLIDWORKS due to the 3D printer limitations. We instead decided to attach string in place of the cables. To analyze the structural properties of the bridge, we created a model in SAP 2000. While this deformed shape diagram is exaggerated, it shows how the bridge will deflect under a static load. The bending moment diagram shows large moments at the connections between the towers and the cables, as well as at either end of the road spans. The force diagram shows large forces in the supports and at the top of the triangular arch. The results of the analysis will not be 100% accurate due to the estimated dimensions and approximated materials. This project was essential in instilling practical experience of taking a project from design to modeling and eventually construction. It also helped to build team values as we worked together to split up the project into different roles. The designer worked to digitally build the SAP model while the builder designed a printable one in SOLIDWORKS. This was all coordinated by our manager. These 3 roles are representative of the 3 main roles in an actual construction project. When the architect, engineer, and construction contractor work in unison, a great work of structural art such as the Leonard P. Zachem Bridge can be made.